right, hey everybody, let's talk about fractions and how big they are and how small they are and which one's bigger and which one's greater than and on and on. This can be very confusing if you don't really understand the fractions, and one way to get there is by looking at a number line. So let's take a look at a number line. Well, this isn't a number line, this is a fraction. And I can see that there are, let me get a good color here, there are, let's see here, 1, 2, 3, 4, 5, 6, 7, 8 pieces here. So I'm going to call those pieces 8s. All right, and we're looking at 4 of them being colored in, so I'm going to say that's 4 8s. Now, I know if this was a candy bar and someone broke it off at 4 8s, it looks like that is about halfway. In fact, 4 is exactly half of 8, so we know that's half. All right, so if I were to try and mark 4 8s on a number line, I would put it where? Well, remember, fractions usually fall between two whole numbers. Now, if you had 4 eighths of a candy bar, would you have one whole candy bar? Absolutely not. So it's going to be less than 1. Would you have 0 candy bars? No, of course not. You'd have more than 0. So what we're going to do is figure out where it's going to go between the 0 and 1. Now, in your mind, you know it's halfway, right? So this is easy. But let's say if it weren't so easy, what would we do? Well, we would need to mark 8 pieces. And these pieces have to be equal. So usually if it's an even number, we start in the middle. And that's 2. And then I need a group of 4 on this side. And I need a group of 4 on this side. All right? So 4 and 4. Oddly enough, it means I'm only going to draw 3 lines. And now I have 1, 2, 3, 4 spaces. And over here, I'm going to do the same thing. 1, 2, 3, and that gives me another 4. So 1, 2, 3, 4, 5, 6, 7, 8 spaces, right? That's what we want, 8 spaces. And I am going to put this fraction at 4 of them. So 1, 2, 3, 4 eighths is halfway between 0 and 1. Okay? It's less than 1. And that's a little bit awkward for some folks. Okay, let's take a look at some other fractions, maybe a little more complicated. Let's say you have a fraction that's more than 1. All right, let's take a look at this diagram. That represents, let's see, it's going to be about 2 whole numbers, right? These are our whole numbers, a whole candy bar, another whole candy bar, and then it looks like it's going to be 1, 2, 3, 4, 5. It's going to be 2, and then I have some fifths, right? 2 and 3 fifths. All right, so how are we going to put this thing on a number line? We're definitely going to need a number line that goes over 2. So, I mean, you're familiar with this. Number lines go on and on. So let's see if we can fill out and orientate ourselves on the number line. Where on earth are we on this number line? Here's 0, here's 4, and it looks like it's broken into 1, 2, 3, 4 pieces. So are these lines fractions? No, they're going to be whole numbers, right? It's 4 because this number is 4. This number would be 1, 2, 3. So can we put fractions on this number line? Sure. Let me erase these little loops here. Sure we can, right? But the question is, what kind of fractions do we need? Well, this is marked in fifths. So I want to break them into fifths. So 2 and 3 fifths. So I could start here going 1, 2, 3, 4 equal pieces, 5, 6, 7. But I don't need to do that because I know that this number is 2, right? Our whole number is 2. Get my pen here. 2. I know it's going to be greater than 2. And it's going to be, it's not quite 3, right? We have 2 and 3 fifths, but that's less than 3. So it's going to be in here somewhere between 2 and 3. So this is really the only place I should cut into fifths. 1, 2, 3, 4, and 5 fifths, of course, would be 3. So first of all, figure out your whole number. It's got to be greater than 2, so it's going to be in between here. It's going to be less than 3, right? It's not yet 3. I could keep counting and get to 3, but it's not there yet. So it's going to be between these two. Then I'm going to look over here at the denominator. I'm going to count fifths. There are 5 pieces here, so I'm going to try and mark 5 equal pieces as best I can. And then I'm going to look at the numerator, right? How many of those fifths do I have? Well, I have 1, 2, 3. So right here is where our number 2 3/5 is going to be. 2 3/5. Okay? So that's how you find these mixed numbers on a number line. Now, we've got pictures here to help us out, and we've got number lines to help us out here, but often we don't, right? Often you're going to be just asked, hey, which of these two fractions is bigger, right? Which ones are bigger, right? Let's just take a look at a couple. Here, let's try 3 6/10. Ooh, and let's try 4 9/13. Well, if I asked you which one of these is bigger, it should be obvious. This number is 3 and a little bit more. This number is 4 and a little bit more. So 4 is more than 3. So think about this as the ones place and the fractions place, right? If I asked you which is bigger, 39 or 41, you wouldn't get confused and say, well, 9 is bigger than 1, well, because we know about place value, right? So since the tens place here, 3, is smaller than the tens place here, we know that this is a smaller number and this is the larger number. It's the same with fractions. The ones place here is smaller and the ones place here is bigger, so this is the bigger fraction. All right, let's try some other ones. Maybe something that's not so close. Let's say, what if we have 4 1/3, and we want to compare that to 4 6/10. Do I need to draw a number line that starts at 0 and goes to 1 and goes to 2 and goes to 3 and goes to... No, because I'm not going to use any of this, right? I don't care about that or that or that, right? That's not useful. So let's see if we can erase this right here. We don't need a number line that big. What do we need? We need a number line that's just going to show me the fractions that are between 4, right? So let's make our number line go from 4 to 5. And it looks like it's broken into thirds and tenths. This is going to be crazy. So you always want to try and estimate, right? Tenths. If I had 10 pieces, would 6 be more than half of them? Well, if I had $10 and I gave you 6, would I have given you more than half my money? Sure. So 6/10 is over half. It's down here somewhere. And 3, let's do the same experiment. If I had $3 and I said I was going to give you half, but I only gave you $1, would that be fair? No, you gave me less money than you said you were going to. You said you were going to give me half, but you only gave me $1. I was supposed to get half of your money. So 1/3 is down here somewhere. So it looks like 4 and a little bit would be down here. It looks like 4 6/10 would be up here, closer to 5. So this is the greater fraction, right? Greater than. Because 6/10 is more than 1/3, right? So when the whole number is the same, you just look at the fraction. And in this case, 6/10 is the bigger fraction. I'm going to use my bigger numbers example here, right? If you had 41 and 46, you see that the tens place is the same. So you look at the ones place, and 6 was bigger. Okay? So that's how you can compare fractions and mixed numbers. All right, ladies and gentlemen, this is going on for a long time. I'm going to say goodbye now.